Hello guys, welcome back for another question from the chapter integral functions, and let us see what do we have today. So we have our expression that looks like something given here. So in the numerator we have x raised to the power 3 into sine of tan inverse of x raised to the power 4, and in the denominator we have 1 added to x raised to the power 8, and we have to integrate this whole expression. Now I can see that this question is pretty difficult. It's not easy. So how do we solve this question now? Let me tell you one thing. Whenever you see trigonometric terms, inverse trigonometric terms or the trigonometric terms, then try to make the argument of that function, that trigonometric or inverse trigonometric function, as x or t. It is always better to make that argument as x or t, otherwise question will be pretty difficult. So what do we do here? We first of all assume x raised to the power 4 as t, and then we differentiate it on both sides with respect to x, and then let us see what do we get. So first of all we assumed x raised to the power 4 as t, x raised to the power 4 as t, and we differentiated it on both sides. So we get 4x raised to the power 3 dx is equal to dt, and then we will replace x raised to the power 4 is equal to t in the expression, and 4x cubed dx is equal to dt in this expression wherever we can replace. So what do we get now? After making all the substitutions, we get our final integration as 1 by 4 into integration of sine of tan inverse t upon 1 plus t square. Now we can see that by making this assumption, by assuming x raised to the power 4 as t, our integral function is simplified, or we can say our integrand is simplified. Now what is our next step? If you look closely into the question, you can observe that we have a term that looks like tan inverse t and 1 plus t square. And I hope you very well remember that the differentiation of tan inverse x with respect to dx with respect to x is 1 upon 1 plus x square. So that is our clue. We have to assume tan inverse t as t so that we can eliminate 1 plus t square from the function. So let us see our next step. So we have assumed our tan inverse t as u. Sorry, we have to assume it as u, as we already have a t variable. So differentiating it on the both sides, we get 1 upon 1 plus t raised to the power 2 dt is equal to du. And now we make our substitutions as given. So now moving to the next slide. Our final integrand looks like 1 upon 4 into integration of sine u du. Now this integration is pretty straightforward, as we already know that integration of sine x dx is minus cos x. So let us see the step. Yeah, so we get 1 upon 4 into minus cos u plus c, and c is our arbitrary constant. Now before signing off with the final answer, we have to remember that we are getting the final answer is in the terms of u, but our original question was in the terms of variable x, so we have to back substitute the value of u, that is written over here. So our u was tan inverse t, so first we may back substitute u one time, that is tan inverse t. Now t has to be back substituted to x, so we get our final answer that looks like minus 1 by 4 into cos of tan inverse of x raised to the power 4 plus c, that is an arbitrary constant. So